Alright, let's begin. So for this video, we're going to be doing dead reckoning for the server-side prediction, or for both sides of prediction. As you can see here, we're using the same bad networking as before, but this time we added jitter, so we have 25% loss, 100 millisecond latency, and 10 milliseconds jitter. So I'm just going to start this up. The first thing to note is our times have been synchronized. So I can see over here, both of them are at roughly 25 seconds at the same time, despite the server starting well before the client got on. Right. Okay, so that's 1 win for the player. Now we'll move over to the server to get their win. Lastly, have the player walk into their own mine, and you can see both sides have their win successfully. Similar to with the client side prediction, to showcase that these things work, or the other tools work, we have the server manager over here. This one's using the normal strategy pattern over here, and this one is using the recording. So if I go into playback mode, you will be able to see that despite clearly no network connection because the server's not even running, we will be able to play our game still, and it starts exactly at the time that we were trying to display. So while this is running, let me mute it, and I will talk about the play side prediction, or the dead reckoning on the client side. So for dead reckoning, we have similar things on the client side of calculating the predicted position. The main difference here is we're passing in a lot more data, so this time we are actually being given the velocity rather than having to guess it ourselves. So whenever we predict our position, we compute P1 to be our position times the given velocity times the change in time, and that is then updated to be, the position is updated to be the calculated position, time is updated to be the calculated time, and then we set the position and angle. As you can see over here also, our recording ended and we're not crashing. Okay. So the position messages now have been changed, and also real quickly, this was the dead reckoning for the missile. Dead reckoning for the ship also has the same exact setup of position, velocity, change in time. Update the position and time, set the angle and position. So that's how the dead reckoning side of this is set up. Both the go to game objects. Both of the ships and the missiles have their own predictive tools here. The main difference here between player prediction and dead reckoning is that because we have missiles using having constant velocity, when we create our dead reckoning tool, we can actually set it in the beginning. So once we have that, we can set our pixel velocity, position, degree, angle, and time. So this will set it immediately, which will segue me into the other change of position. Position now is only for ships. We do not need to do any prediction for missiles, so we check to make sure that we're given a valid ID. When we know that, we can set the data for our prediction tool on the client side. Like I mentioned, we also have the velocity now being stored in, so we're getting that extra data from the server. Swapping over to the server now. Oh no, and really quick back to the client. For game scene play, at the end of the frame, we are predicting the missile position and the the ship's position at the end of each frame. Now moving over to the server. For the server, let's see, no, I did not compute here. Okay, so for the server, when we go to over here, where is my data queues? So for the server, whenever we send the game state, since the server also has to be running these computations, we have the server doing the same exact thing that the client is. So we both have they also have the dead reckoning for the missile and the ship over here. This one I did not break off. I wasn't doing as much debugging on this side. But the difference here is they have the angle threshold for these values, and they will return if they notice anything too much of a deviation from that value. Um, so to hop back to here, the normal gameplay. So if we find a value here, if we find that we are deviating from our threshold too much, then we will pass in the position message here. Position is only sent here if we find that the ship is deviating too far off of course. And then that again is setting the position, velocity, angle, and then sending the packet over. The same thing goes for recording. If it were recording, it'd be doing the same thing. And that's it.